Good afternoon, class. We are looking at chapter 8, further application of trigonometric functions. Here's section 8.3, polar coordinates. So we covered the law of sines, the law of cosines, and now polar coordinates. The objectives are plot points using polar coordinates, convert from polar coordinates to rectangular coordinates, convert from rectangular coordinates to polar coordinates, transform equations between polar and rectangular form. Again, reminding everyone of what we have learned so far. Fundamental identities, starting with a unit circle, x squared plus y squared equals 1. Fundamental identities about Pythagorean identities, quotient identities, reciprocal identities. A periodic function repeats its values at regular intervals. All trigonometric functions are periodic functions with the period of 2 pi. In the case of tangent and cotangent, the period is pi. An even function means f of minus x equals f of x. An odd function means f of minus x equals minus f of x. Every trigonometric function is odd except cosine and therefore secant. In a right triangle, a squared plus b squared equals c squared, Pythagorean theorem. A and B, they add up to 90 degrees because the total interior angles must be 180, and this is 90. Sine law indicates sine A over A equals sine B over B equals sine C over C. Cosine law says A squared equals B squared plus C squared minus 2BC cosine A. So if you move things around and solve for cosine A, you end up with cosine A being B squared plus C squared minus A squared over 2BC. We came up with the sum and difference formulas. For example, sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Tan of alpha plus beta is tan of alpha plus tan of beta over 1 minus tan alpha tan beta. And we developed the double angle formulas. For example, here, if I replace the beta with alpha, sine of alpha plus alpha, replace the beta here, I get sine of 2 alpha equals 2 sine alpha cosine alpha. Cosine to alpha, over here, change the beta to alpha, you get cosine of 2 alpha equals cosine squared minus sine squared, and there are 3 different ways of writing it. Finally, tangent is the ratio of sine to cosine. From here, we can solve for sine squared, which is 1 minus cosine 12 over 2. And from here, we can solve for, and we cut it in half. This becomes sine squared of alpha over 2, and 2 alpha becomes alpha. From here, we can solve for cosine squared alpha. We cut this in half. Cosine squared of alpha over 2 is 1 plus cosine alpha over 2. And tangent is the ratio of sine to cosine. So to take sine of alpha over 2 or cosine of alpha over 2, we go with plus minus. And based on the quadrant it belongs to, we make a decision for the sine. And briefly, this concept of product to sum and sum to product formulas. So right triangle. A squared plus B squared is C squared. A plus B is 90 degrees. Sine is the opposite over hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over the adjacent, and the rest of them are reciprocals. Angle of elevation. You have a horizontal plane. If you look up, the angle it creates is angle of elevation. Looking down for this is the line of sight. Gives us angle of depression. So angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal, whereas angle of depression is the angle formed by the line of sight and horizontal plane for an object below the horizontal. Direction, we have two ways. Method one, just compare it to the north, going clockwise, that's all. Method one, the direction of bearing of a point is the number of degrees in the angle measured in the clockwise direction from north, the vertical line, to the line joining the center of the compass with the point. The direction of bearing in the second method, you look at the north and the acute angle, an angle between 0 and 90 degrees. So this one would be 30, we say north 30 degrees east. This one with compared to south, we would say south 20 degrees east. That's how we do the second method. And so direction of bearing of a point O to a point P equals the acute angle theta between the ray OP and the vertical line through O, the north-south line. So that's the synopsis of what we have in this chapter. And now, polar coordinates. In a two-dimensional coordinate system, each point on a plane is determined by rectangular format, x comma y, which is a distance from the x is a distance from the y, and y is a distance from the x-axis. Second method is by polar, r comma theta, a distance from a reference point that we are going to call it pole, and an angle from a reference direction called the polar axis. So those are the terminology that we are going to use: pole and polar axis. Polar axis in essence is the x-axis. So it looks like this. The x-axis is called the polar axis, the positive side. Here's the pole, that means the origin in essence when it comes to understanding that. Now, summary. Plot points using polar coordinates. Here's the summary of the section. Polar, looks like r comma theta, can be represented as r comma theta plus 2k pi. So what happens is that x and y represent a unique representation, whereas r and theta, we can write it in infinitely many different ways. You can add multiples of 2 pi, k is an integer. Or you can make r negative and add a pi. So theta plus pi, or in general, theta plus pi plus 2k pi. K is an integer. Remember the integer 0, 1, 2, 3, and on a negative side. So reminding you that this means 0, 1, 2 to infinity, or negative 1, negative 2 to negative infinity, right? Set of integers. So here's x, here's y, here's the distance from the pole or the origin r, here's the angle that it makes, theta. And because angle can be represented in many different ways, that's why we can write them in various formats. So now, if polar is r theta and rectangular is xy, we can see that x is r cosine theta from the graph, and y is r sine theta. There's nothing brand new here. We've seen this before when we discussed the unit circle and the circles that had the formula x squared plus y squared equals r squared, similar to that concept. Rectangular, x comma y, polar r comma theta. So x squared plus y squared equals r squared, and tan theta is y over x, adjust for the quadrant. Remember, when we calculate this, you have to pay attention to the quadrant and therefore the proper um, angle will be found. We want to plot the point with the polar coordinates 2 comma pi over 4. We know how to plot points in a rectangular coordinate system and now in a polar coordinate system. So how do we start? We start with the angle. Actually, here's the pole. Here's the polar axis. From the polar axis, draw an angle of pi over 4. Go up how many? 2 tick marks. That's the concept. That's how you do the graphing. Here's the angle pi over 4. And 1, 2, 3, 4, 5 indefinitely, and we need 2 of them. 1, 2, because this is to everybody. So 2 tick marks. Pretty straightforward. Here's your pole, here's your polar axis. 2 comma pi over 4, 1, 2 tick marks. So this distance must be 2. Plot the point negative 3 to pi over 3. Well, when that happens, everybody, when r is negative, first you draw this angle of 2 pi over 3, and then you go in the opposite direction. In general, you draw theta, and over here, if you go with the tick marks, those are positive. In the opposite direction, r is negative. So that's how you come up with the answer. And I hope everybody's okay with that. So what happens? Here's your polar axis. Here's your pole. Here's 2 pi over 3. Okay. Let's say it was positive 3. You would say 1, 2, 3, and that would be the point. Because it's negative, you go in a negative direction. You go in an opposite direction, and you go with how many? 3 tick marks. So you go down. So this would be minus 3, 2 pi over 3. So remember, we start with the angle when it comes to polar coordinates. This one is to get us started. With this concept. I hope everybody's okay with that. So we can move on. All right, let's do some more. We want to plot points, 3 comma 5 pi over 3. So here's our polar axis. 5 pi over 3 puts us into the fourth quadrant, just to give you an idea. So that's the angle. You draw the line and you tick mark 1, 2, 3. Okay, 1, 2, 3. So 3 and 5 pi over 3. That's how we do this, everybody. Okay. This one, pi over 4, negative pi over 4, isn't it clockwise? Because it's negative clockwise. So first, we come up with the angle. Then we draw a line and we go how many? 2 tick marks. So 1 and 2. This is the point, 2 comma negative pi over 4. That's what we are looking for. Three comma 0, the angle is 0. So it's just along this line. And go 1, 2, 3 tick marks. That's all you have to do. Pi over 4. So draw the angle pi over 4 positive. Now, if it were 2, we would draw and we go 1, 2 in a positive side. But because it's negative, draw it and go in the opposite side because it's negative 2. So this point, class, would be 2. Let me actually make a point here. This point, let's go back. This point would be positive 2 pi over 4. Now we go this way, 1 and 2. This is negative 2 pi over 4. So this one, let me just write it now that we have done here with a different color. Let's say this color. This one, everyone, has coordinates positive 2 pi over 4, okay? So you want to be careful with that so you understand what's going on, okay? This is how we do that. Drawing, everybody. I want to make sure that you get comfortable with this concept. It's really not too bad. All right. Plot the point P with coordinates 3 comma power 6. So here's our polar axis. Here's the pole and positive power 6. Remember, counterclockwise. And you draw the line here with how many tick marks? 3 of those. 1, 2, 3. So very carefully you come up with that. Okay. So this is power 6, 3 power 6. All right. Reminding you that r comma theta is not unique, unlike x and y that is unique. We could say r, same theta, and add multiples of 2 pi, 2k pi. We can make r negative and then add pi. When you add pi, you can keep it just pi, or not only pi plus 2k pi. In other words, 2k plus 1 times pi. Odd multiples of pi. That's the meaning of pi plus 2k pi. Let me write that so everybody can see what I'm talking. This is the same as writing 2k plus 1 times pi. Odd multiples of pi. You can do that. In any event, part A, plot P, point P, such that R is positive. Okay, so we want the same R there. But theta is between 2 pi and 4 pi. So this is power 6. This is in the second revolution, if you will. So just add 2 pi. That's what it means here. Add 2 pi. So add 2 pi to what? To the angle pi over 6. When we do that, 2 pi is 12 pi over 6. With this one, we get 13 pi over 6. Okay, just to give you an idea. So add 2 pi. So you get 3, and the angle is 13 pi over 6. So you have gone a complete revolution and another pi over 6. This time we want to make R negative. So we want 3 to become negative. That means negative 3. However, we want it to stay within the first revolution. That means all you have to do, add pi. Just add pi. That's all you have to do. It's very straightforward. So change this to a negative, and this angle, add pi. So now negative 3 pi is 6 pi over 6, and pi 7 pi over 6. So take a look. We are going to go 7 pi over 6. That means going this way. However, because it's negative, we go the opposite one. So take a look. 7 pi over 6 means this way. Since this is negative, go back 1, 2, 3, tick marks. All of them are the same, everybody. So hopefully everybody's following that and everybody's comfortable with the concept. Plot P such that R is still positive, so we want the same 3, but this time is between negative 2 pi and 0. It's a negative angle we want, so no problem. Instead of adding 2 pi, let's subtract 2 pi. It gives you the same location. So we are going to subtract 2 pi. Of course, we are dealing with the angle only. In this case, so 12 pi over 6 minus 12 pi over 6 makes it negative 11 pi over 6. So we are going minus 11 pi over 6, right? In a negative direction, clockwise direction. That gives us this one. So negative 11 pi over 6. So P now has coordinates 3 minus 11 pi over 6. So P has coordinates 3 pi over 6, 3, 13 pi over 6, negative 3, 7 pi over 6, positive 3, negative 11 pi over 6. They are all the same, everybody. They are all the same. Hopefully that's clear and straightforward too for everyone. All right. So that's the concept you need to be comfortable with. One more time. This is not unique. Convert from polar coordinates to rectangular coordinates. So in essence, you are putting the two grids together. We have a rectangular coordinate system and we have a polar coordinate system, X, Y, or theta. Polar is R comma theta. Rectangular is X comma Y. X is equal to R cosine theta. See, cosine of theta is the adjacent. Let's just write that to make sure we are comfortable with the concept. So if you look at this, cosine theta is the adjacent X over the hypotenuse R, and that results in this X being R cosine theta. On the other hand, sine theta is the opposite of theta, Y over R. That gives us Y equals R sine theta. So that's the relationship between the two. And here's a different color. We know that tan of theta is Y over X. That's why we get theta as tan inverse of Y over X, and we adjust it for the quadrant. We just look at the quadrant, make a decision to make sure that it's correct. We are going to move on, everybody. Convert from polar coordinates to rectangular coordinates, 6 comma pi over 6. So we put the rectangular coordinate system and a polar grid together. So we have the x and y axis. We make up the angle of pi over 6 and we go 6 tick marks. So it looks something like that. X is r cosine theta. So this is r 6 cosine of pi over 6. And of course, that's a common arc. Cosine of pi over 6 or 30 degrees is square root of 3 over 2. So 3 square root of 3 is the x coordinate. The y coordinate is r sine theta. R sine theta. So we use the same thing. 6 sine of pi over 6. Again, common arc. Sine of pi over 6 or 30 degrees is 1/2. The product of 6 and 1/2 we know is 3. That means this is 3 square root of 3. This is 3. And this point has polar coordinates 6 comma pi over 6. Rectangular coordinates 3 square root of 3 comma 3. That's the meaning of it. Very straightforward, everybody. Again, we're going to do the same thing here. We are going to have a rectangular coordinate system and polar grid together. Pi over 4 is in the counterclockwise position, but minus is in the clockwise direction. So go pi over 4, but in the negative direction, counterclockwise. Because this is negative 4, instead of going 1, 2, 3, 4 tick marks in the same direction, you go in the opposite direction because this is negative. So first, this is minus pi over 4, and this is positive 4, 1, 2, 3, 4. Since this is negative, we have to go in the opposite direction. So let me just go back one more time. First, I want to show you the positive 4. So negative pi over 4 is in the negative direction, clockwise. And then you go 1, 2, 3, 4 tick marks. If we go in the opposite side, makes it negative 4. So what we are looking for is this. All right, x equals r cosine theta. That means x equals negative 4 times cosine of negative pi over 4. Cosine is an even function. So this is minus 4 cosine of positive pi over 4. Again, just because class cosine of minus x is the same as cosine of x. Cosine is an even function. So minus 4 times cosine of power 4, which is square root of 2 over 2. This goes away. This changes to negative 2. So negative 2 square root of 2. So that's pretty straightforward, everybody. Y equals r sine theta. So write it down. Now sine is an odd function. So what you're looking at here is minus 4 times minus sine of power 4, which makes it positive 4 sine of power 4. So 4 times square root of 2 over 2, we get 2 square root of 2. Now, therefore, this is negative 2 square root of 2. This is 2 square root of 2. And the polar coordinates negative 4 comma negative power 4 are the same as rectangular coordinates negative 2 square root of 2 comma 2 square root of 2. So I hope it makes sense to everybody. We are going to move on. Convert rectangular coordinates to polar coordinates, and the pair given is 0 comma 3, and reminding you rectangular is in the form of x and comma y, polar is r comma theta, x squared plus y squared is r squared, tan theta is y over x. It's just for the quadrant. R comma theta is the same as r comma theta plus 2k pi, meaning add multiples of 2 pi. If you want to change the r to negative, then theta plus pi plus 2k pi, and this means odd multiples of pi. That's the meaning of it, everybody. Okay. So I hope it's clear to everybody. And now, what do we do? Number one, plot the points. If you're given a bunch of points, just plot them. In this case, 1.0 comma 3. 0 comma 3. That's the location. Zero comma 3. Determine r and theta, because we want to go from rectangular to polar. Here's the theta power 2. Here's r number 3. So you write down r is 3, theta is pi over 2. R is 3, theta is pi over 2. So that's pretty straightforward. Now we want to write them in different manners. Let's start with the first one. It says R must be positive and theta must be in the first revolution from 0 to 2 pi. So R comma theta simply becomes 3 and pi over 2. That's all. So we are done. If the question was just flood the points and change it to polar coordinate, this is one way and the easiest way to represent that. You're done. Finished. Okay. But there are infinitely many different ways of representing a point with polar coordinates. Infinitely many different ways. So we're done with part A and we are done. However, part B says, okay, we want to keep the R positive, so 3, but this time we want it to be in a negative direction from negative 2 pi to 0. So basically, subtract 2 pi or add negative 2 pi. That's how you get there. So pi over 2 and negative 2 pi, pi over 2 and negative 2 pi, they add up to negative 3 pi over 2. So 3 comma negative 3 pi over 2. That's part B, everybody. Part C says, okay, we want R to be negative, so you have to change this R to negative 3. And theta between 0 and 2 pi, the first revolution. And you remember, all you have to do, add pi. So change this to negative, add the pi. So pi and pi over 2 gives you 3 pi over 2. And this gives you the same location, everybody. So there are different ways of writing the same point in polar coordinates. What I want to add is going back to this format, if you want to keep this number 3 and it's between 0 and 2 pi, that's the only way to write it. You're done. However, if they say we want R to be positive, that's all, and they don't say anything else, you can change this to many, many different formats. For example, if I added 2 pi to this, I get 3 and 5 pi over 2. I can add another 2 pi, subtract 2 pi, add 4 pi, 12 pi, you name it. There are infinitely many ways of writing this. And this is extremely important to understand, everybody. There are infinitely many ways of writing this polar coordinate.